Okay, so these are our 612 notes. So in our note packet, we are looking at page 3. I do know that I already have these kind of updated online for you too, but it's good to talk about it at the same time so that we get some more practice. And actually, the one that we went over on the homework was a perfect question because that kind of brings us right into this very first set of triangles and where we're asking to find, are they congruent? Do we have enough information to determine that? So even though it doesn't have the 9 and the 13 listed on it like it did on the homework, this is the same set of triangles. We have our ABC and our DEF, and we already were able to tell that based on this information, it says if they have the relationship shown at the right, do they have to be congruent? Well, we already showed, there we go, that this AC, oops, let me get a marker here. This side AC and this side DF had a one-to-one relationship because we can see these marks here mean they're equal. So it doesn't really matter what number they are. In our homework, it was a 9 and a 9. We could say it's a 5 and a 5 or a 3 and a 3. The marks just simply mean that they are equal. So we know that those have a one-to-one ratio already. We also can see that AB and DE have the same markings, that little double set of marks on them. So they also have a one-to-one ratio. In the homework, it was a 13 and a 13. It could be a 10 and a 10. It could be a 4 and a 4. It doesn't really matter because it just means that they are equal. They have a one-to-one ratio. And we can also see that our angle A and our angle D have the same value as well. So again, in the homework, those were a 65-degree angle. Here, it doesn't really matter. As long as they're equal, that's what we needed to show side angle side. So we knew that they were similar, and we were able to prove, and we can see because of the markings, that they have a one-to-one ratio. So yes, they are going to be congruent. And again, same reasons as we had on the homework there. I'm gonna move myself over here and I'll just type it out because my handwriting is horrible. There. So I just typed it in. They are similar triangles with a one-to-one ratio between the sides. Okay? The sides are the ones that need the one-to-one ratio, not the angles. Angles have to be equal. I got a question over here. Okay. So it says then, write a conjecture in the form of a conditional statement or arrow diagram. I kind of have it set up for us as a conditional statement already, meaning a statement with an if and a then, based on this relationship. Remember, a conditional statement looks something like, if two triangles, blah, 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 then the triangles are congruent. So I already have it kind of filled out for us that we're just going to fill in a couple of pieces of information from what we see in our diagram. So it says if the triangles have blank pairs of equal corresponding blank and the blank between the two blank is equal, then the two triangles are congruent. So what on earth are we talking about here? So we're talking about pairs here. So we can see in this picture they have two pairs of equal corresponding sides. Okay, so AC and FD, I'll even put them in. So AC and FD were equal. That's one pair. And then we had our AB and our DE were equal. So that's our two pairs of equal corresponding sides. So we have that, and the angle between the two sides is equal, then the two triangles are congruent. And we can see that that angle in our picture was our angle A equal to our angle D. So if we have all of that information, we have two pairs of sides that are equal to each other, and our angle in between them is equal to each other, then that is enough to say our triangles are congruent. We no longer have to say they're similar first and then check for a one-to-one ratio. If we can already see they're equal, Why do we have to go to similar before we can go right to congruent? So why take the extra 2 steps to get around to our answer? So then it's like, well, what's a good name for this shortcut? Well, kind of. We've got a side, let me see here, that matches. We've got an angle in between that matches, and we have another side that matches. So it looks just like our similarity, but now instead of saying that the triangles are similar, we're going to say the triangles are congruent. So what we'll do is we'll just kind of copy over. We'll say it's still side angle side, but now instead of the similar symbol, we're going to put the congruent symbol. So we just put an equal sign underneath, and then now we're talking about congruence versus similarity. So that's a nice shortcut because it allows us to quickly say they're congruent without having to go through all of the big steps. So we have a couple other shortcuts we're going to look at today too. So Derek wonders what other types of information can help determine 2 triangles are congruent. So we have 6, we can see here there are 6 tests that we're going to run. Do they have the side, the similarity? Do they have the 1-to-1 ratio? If that's true, then we can kind of shortcut it. We're gonna add this to our blue sheets here in just a little bit. So we know that side-side-side similarity exists. We want to know, does side-side-side congruence exist? So what they're saying here is, notice no measurements are given in the diagrams. So we're considering the general case of each type of pairing. So if we want, we can throw numbers in so that we can check it. But they're saying it doesn't matter what numbers we use, it's going to work no matter what. Or it will work or it won't work no matter what. So looking at our first set of triangles, we're trying to check, does side-side-side congruence work just like the side angle side congruence worked? So do we have similar triangles with a 1-to-1 ratio existing? So here we can see all 3 sides. So A matches with A, B matches with B, C matches with C. So if those match, is that enough to say the triangles are similar? Yes, they would be similar by side-side-side. And then the question is, does a 1-to-1 ratio exist? At least one pair of corresponding sides is equal. Well, yeah, we can see. And actually, in this case, we have 3 pairs of corresponding sides that are equal. A matches with A, B matches with B, and C matches with C. So yes. So that means this works, and side-side-side congruence is a thing. And we'll add this to our blue sheet here in just a minute. So then the next one we have here is our angle, 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 or AAA congruence. Is that a thing? So first thing we need to know, are the triangles similar? Could we use side-side-side or side, angle, angle to prove the triangles are similar? Well, we could prove they're similar by angle, angle. At least 2 angles. Here's one with a triple mark. Here's one with a triple mark. Here's one with a double mark. Here's one with a double. So we do have at least 2 angles, and in fact, we have all 3. So yes, they're similar. But do they have a side that's given to us that's equal? So like in the first triangle, we knew that A matched with A, B matched with B, C matched with C. We had that information. In this second pair of triangles, we don't have any sides are equal. So no, this one does not work. We don't have a 1-to-1 ratio, so this would definitely be a no. Angle, angle, angle congruence is not a thing. Okay. So what about angle side angle congruence? Is that a thing? So could we prove with angle side angle that we have similarity in some way? So do we have side, side, side? Are all 3 sides marked with something? No. Do we have side angle side? Do we have 2 sides marked with an angle? No, we only have, and in this case we can see we only have 1 side marked. Do we have angle, angle? Is there an angle in one triangle and then a second pair of angles in the triangles equal? Yes, we do have angle, angle congruence or similarity. So we have two pairs of angles in both triangles that are similar. So then the next question is, do we have a 1-to-1 ratio? Do we have a pair of sides that's equal? So, and it says corresponding sides. That's the important part here. So when we look at this M, we can see we have an M and then another M. We do have the same letter. Is it in the same spot? That's the big question. So this M that we see is in between the two angles. And is that the case over here as well? Is the M that they give us in between the two angles? Yes. So because M equals M, we have a 1-to-1 ratio. So that means this is another shortcut that we could use for congruence. So meaning we don't have to then always say, you know, if we have a picture that looks like this, we don't have to every single time go, all right, well, I have similarity and I have a 1-to-1 ratio. I can say, oh, I have two angles and a side in between. They're done. I don't even have to go into all the detail. So it gives us a way to shortcut this. All right, so then on part D, do we have side-side angle similarity? I'm sorry, congruence. Side-side angle. So we do have two sides and an angle, so we want to know, do we have similarity at all first? Because again, those are the two requirements. They have to be similar with a 1-to-1 ratio. So do we have side-side-side similarity? Well, I have a Q, oops, let me undo that one. Try that again. I have Q matching with Q, and I have R matching with R. So I have two sides, but I don't have the third side given to me. I don't know how big this side is, and I don't know if it matches the one over here. So nope, side, side, side is not how I'm going to prove they're similar. Do I have side angle side similarity? I do have two sides. Remember that our angle, come on, let's try that, there we go. Our angle is supposed to be in the middle. So this angle that they gave us that's congruent is supposed to be between the two sides, which means that it should actually be up over here in between Q and R, and it's not. So while it looks like it should work for side angle side, the angle's in the wrong place. So this is not going to be a similarity method. And then also angle angle, we only have one angle given to us. We don't know how big the other two angles are. So we can't do that either. So right off the bat, we can't even prove they're similar, let alone having a 1-to-1 ratio. Two sides is not enough. We'd need all three. Or the angle they give us has to be in the middle, and it's not. So this does not work. So we don't have to worry about it. You could cross it off the list. And remember with similarity, remember we had like our side-side angle. If you turn it around, it's angle side-side. And we were like, yeah, you can't use that. It spells a bad word. So this is another one of those where it's like, nope, doesn't work. What if instead of side-side angle, we said angle, angle, side? So can we prove that they're similar and that they have a 1-to-1 ratio? So based on our similarities, we have three ways to show they're similar. Side, 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 we don't have three sides. Side, angle, side, we only have one side. Angle, angle, hey, we do have an angle here and an angle there. And we have another set of angles. So we do have two angles. Yes, so they are similar. Do we have a 1-to-1 ratio? At least one pair of corresponding sides is equal. So this is the big important part with this one. This was where it gets a little tricky. We have a side that's marked congruent. It's after, in my case, it's after that red angle. When I come over here and look, is that the same side? So if I put, I don't know, like an A here and an A there, are they in matching positions? And they are. Okay. If that side they gave us that was congruent was after the green line or the green angle, then they wouldn't be in the same placement. So that gets tricky. Most of the time we don't, we're not trying to trick you guys. We will give you them in the right positions, in the corresponding parts so that you're not trying. there's enough going on here. We don't need to try and trick you on that, on top of that. So yeah, so this is one that works. Angle side is a congruence method, just like angle side angle is a congruence method, because we have two angles and a side that shows a 1-to-1 ratio. All right, the last one is a tricky one. It doesn't come up very often. It says hypotenuse leg congruence. So the big question here, and the big thing with this one, is this is a right triangle. Notice specifically, these are right angles where all of the other triangles were not. So with this, if it's a right triangle, we can do Pythagorean theorem. We could do a squared plus b squared equals c squared to find our missing sides. And if we know that, I'm just going to put a little hypothetical out here. This is one where putting some numbers actually helps. Let's see here. If this was, I don't know, a 5 and a 4 in a right triangle, do we know how to find the missing side? Yeah, we can do our Pythagorean theorem. So I could do a squared plus 4 squared equals 5 squared, or in this case, x squared plus 4 squared equals 5 squared, and I could come up with my answer. Well, if we were told that in the other triangle, the sides that they gave us already match, if I already know that this is a 4 and this is a 5, well, wouldn't it make sense that these two sides would have to be the same because they're both right triangles and they have the same side missing? Yeah, so we could then figure out that both of these sides have to match. I know I didn't draw that very accurately, but that's okay. So we could, because it's a right triangle, we could do Pythagorean theorem and we could figure out the missing side. The goal here is that we don't have to do Pythagorean theorem to make these work. So we will be able to prove they're similar. In fact, we could prove they're similar by side, 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 or by side, angle, side. We couldn't do angle, angle, because we wouldn't have two angles. However, shoot, if it's a right triangle, we could do sine, cosine, or tangent and do the inverse and find an angle measure. So I guess actually we could do any of these because right triangles are special. They give us information that other triangles don't. And if we know that the sides are equal, because they gave us two sides, then a 1-to-1 ratio must exist. So it does work. HL is a thing. It's a very special thing, but it doesn't come up very often because it only works for right triangles. Okay. So here again, I have a slide here. I'm going to leave up. If you have your blue sheets, I would grab them out so you can write these down. I'm going to write it down kind of with you guys as we're doing it. And then I'm going to post it online as well. I know I didn't post the one from yesterday because I was like, it was just yesterday. And I wanted to fill out a little more of this before we got too far ahead. So these are the 5 methods that we just talked about. So we know HL is a method, angle, angle, side is a method, angle, side, angle, ASA is a method, and side, side, side is a method. And then we already worked with SAS up here. So we have 5 methods total that are shortcuts for proving congruence as opposed to saying, are they similar and do they have a 1-to-1 ratio? You can always fall back on that, but it's kind of being extra, and who really wants to be extra? So these are our 5. I'm going to leave them up here. If you don't have your blue sheet or you're not planning to write it down, take a little brain break maybe here as some other people get these filled out. And then we'll reconvene here in just a second. So I'm going to fill mine out too, kind of read them as we're doing them, just to kind of reiterate these methods and how we use them. And then we're going to use them in a couple of flowcharts, like 6 flowcharts. So our first one was our side angle side congruence. Use this color. No, I'm gonna use these pens. I had to decide what I'm gonna write with before I actually start writing. Maybe you want to bubble around those or something. These are the shortcuts. These are the names we're going to need to know. And then I have like some words describing them underneath. So we have if 2 pairs of corresponding sides are equal and the angles between them are equal, then the triangles are congruent. So we have 2 triangles here. We can see they've got some sides that are marked. They've been rotated a little bit, so they're a little tricky. You got to kind of turn your head for the second one in order to make them make sense. But I'm putting the SAS in the picture so that you can see how they relate to one another. And actually, I'll even do this. I'm going to change the color on these. Let's make that blue. I wanted to make it stand out. Ooh. There we go. There we go. So we can see these similarities and how they all work. Oops. No, don't do that. Yeah, that's all right. So we have a side AB that matches with that side ED. We have our angle B that matches with our angle E, and our side BC that matches with our side EF. Okay, so side, angle, side. Our next one we have is our side, side, side. That was the next one in our chart that we were working through. So side, 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 SSS congruent symbol. And this one is probably the easiest one to identify. All 3 sides of all 3 pairs. Oops, dang it. Pairs. Whiteout. All 3 pairs of corresponding sides are equal. There. So all 3 pairs of corresponding sides are equal. Then that makes our triangles congruent. So we have side BC is corresponding with ZY. We have side AB is corresponding with side XY. And we have our side AC corresponding with side XZ. Side, side, side congruence. Okay. And I'm going to move myself out of the way here. There we go. So we have our other 3 that we are working with at the bottom. Our angle side angle congruence. Okay, so now we have two pairs of corresponding angles. Are equal, and the sides between them are also equal. Then that makes our triangles congruent. So in our picture here, we can see angle B and angle E. Those are our right angles, are congruent. We have our angle C and our angle F are also congruent or equal. And then the side between them, BC, matches with our EF or FE. And that gives us angle side angle. You can almost read it if you mark the picture with those the letters for their parts. You can almost read, like even if I was to put the S up here, we can read it straight across. It says ASA as I look at the picture. So it's a way to kind of just make sure that we're doing it right. I like putting the S's on the outside because they're sides, and sides go on the outside and angles go on the inside. But I'm just moving this so we can read that a little bit more clearly. Alrighty. So our next one is our angle side congruence. We have two pairs of corresponding angles again, but this time the corresponding sides not between them. We call them non-included sides. It's another word for it. So I'm going to write this: two pairs of corresponding angles are equal, and the corresponding sides not between them are also equal. So we can see our angle B matches our angle E, our A matches our angle D, and our side AC, not in between the two angles, matches with our side DF, not in between the two angles, following in the same order. That's the trick. It's the order that matters. And then lastly, our HL. And this one is the tricky one because it's only for a right triangle. So if the hypotenuse and one leg of a right triangle are equal to the hypotenuse and leg of another right triangle, then the triangles are congruent. So the big deal here is that they have to be right triangles. If they're not, then it doesn't work. And that's because then you can't do the Pythagorean theorem to show that they are, in fact, always going to be similar. So you need the right triangle to be able to say that they work. Okay. I'm just looking to see. Okay, I was trying to remember what I had in here. So I know that took me a little bit on that same slide, just kind of reading through. I was also writing mine in there too, so I will post that online. Obviously, I have the notes posted already, but I don't have the blue sheet posted yet. So I just wanted to make sure that everybody had the same amount of time as I did to fill it out so that, you know, you have it. And if you don't have it, it's not a bad thing to hear me saying it either.